Assalamualaikum and good morning to all my students of Mev321. So for today we are going to learn our final chapter about the brake system. Basically this is the chapter 5, okay, for our new syllabus, and I have updated these slides, and I already uploaded into your Google Classroom. Okay, so make sure you download the latest updated version of this note. Okay, so let's get started. So these slides tell you about the introductions of the brake system. As already know, the function of brake is to slowing, stopping, and controlling the vehicle. And when we park the vehicle, we also have to use the brake system to make sure the car fits to that position. Okay, and the braking principle of the brake system is based on kinetic energy of vehicle is to converting into heat, which dissipated into atmosphere. Okay, so we have many of classification, and the brake systems is classified based on the type, how the working medium, and the technology, and also by the end use. So for the bike type, there are two types that are commonly known nowadays. There are disc brake and drum brake. So hopefully every one of you have already heard about this disc brake and drum brake. Okay, and then by working medium, they classified by the hydraulic and also pneumatic braking system. Okay, so most of the modern cars right now are using the hydraulic braking system. Okay, and some of the commercial vehicles use pneumatic and mix of both hydraulic and pneumatic braking system. Okay, and then by the technology, there are a lot of new technology. So in these slides, maybe it is not updated version. So based on this picture, there are only 3 anti-lock braking system, electronic stability control system, and regenerative braking system. But there are more of new technology, okay, that are developed on the brake system. Okay, so the 3 here mostly widely used in our modern cars. And anti-lock braking system, the short form is the ABS. We have already done this or learn about this during our practical session, okay, during our laboratory experiment 2, if I'm not mistaken. Okay, and by end use, there are classified based on the passengers cars, like commercial vehicles, heavy commercial vehicles, and two-wheelers, motorcycles, and so on. Okay, so there are also 2 types of brake in our cars. One is the parking brake. Yes, of course, it's for the parking. And one is the service brake. Service brake that you press on the pedal, on the foot pedal, and the car is slowing down. So that is the service brake. Okay, so this is a diagram shows the exploded components of braking system. Okay, this basic one where we have release button there for the brake, parking brake, parking brake lever, vacuum brake booster, and so on. So some of these components will be discussed later in the slides. Okay, so the easier diagram here shows that if you use the drum brake there for the typical drum brake, and we also use the drum brake for the rear brake, front brake there, we have disc brake. So for this car, we have disc brake in the front and the drum brake at the rear wheel. And so we have the master cylinders. This is like a heart of our brake system that composed of many components such as the pistons, pump, and so on. And then when we press the brake pedal, it actuates the master cylinder to send the hydraulic power. Yes, the hydraulic oil there, the one that we call the brake oil. Okay, it used as a medium, energy medium, that convert the hydraulic power into the brake lines and finally to every wheel. Okay, so when you press, so the hydraulic power transmitted into the disc brake at the front and the drum brake at the rear wheel. Okay, so this slide is very comprehensive. It details in notes there. So let's watch this YouTube video first to make sure you know overview how the brake functions.
Tukar setiap saat kepada saat keemasan dengan KFC Golden.
Let's take a look at the components that make up a typical hydraulic braking system. We have the brake pedal, the push rod, the servo, the master cylinder, the reservoir.
So the reservoir here is the tank of the tank that you put it the brake oil. Most of the time we use the dot for oil. Okay, so this is the indicator where you have to regularly check either the oil oil level is on the safety what we call the adequate volume of oil.
And hydraulic lines. The brake pedal transfers the mechanical force applied by the driver to the push rod. The push rod transfers the mechanical force applied by the brake pedal through the servo to the master cylinder. The brake servo or vacuum booster assists the driver by applying additional force to the brake.
Okay, the servo there is also known as the vacuum booster.
Braking system. The master cylinder converts non-hydraulic pressure from the driver's foot on the brake pedal into hydraulic pressure. When braking, pistons with seals and springs in the master cylinder create hydraulic force, which pressurizes the entire hydraulic system. Brake fluid returns to the master cylinder when pressure is released. The reservoir holds sufficient brake fluid to stop air getting into the hydraulic system. Finally, we have the hydraulic lines, which carry the brake fluid to the front and rear brakes. Now, let's take a look at the hydraulic system in action. Here we can see the wheels turning. Pressing the brake pedal extends a push rod through the brake servo and into the master cylinder. The master cylinder pressurizes the entire hydraulic system and forces brake fluid through the hydraulic lines. Releasing the brake pedal reverses the process. The hydraulic pressure on the entire brake system is reduced, allowing brake fluid to return to the master cylinder. A combination of seals in the caliper and springs in the brake drum then return the brakes to their original position, allowing the wheels to turn freely once more. Brake fluid travels through the hydraulic lines, applying pressure to the caliper or wheel cylinder pistons, which in turn create the friction force required to slow the wheels. And that's the basics of how a hydraulic brake system works.
Okay, so that's the basic of our brake system. And that's okay, so to get details information how the brake actions, you have to read and understand one words by one words in these slides. So the service brake system includes two basic parts. These are the master cylinder and the drum, and this wheel brake mechanism. The master cylinder is a reciprocating pump, so we have a reciprocating pump in our master cylinder. If we do not have that pump, we cannot pressurize the brake oil to give the hydraulic pressure to the disc brake or drum brake. Okay, it pressurizes the hydraulic system. Okay, I have mentioned. This convert the mechanical force from the brake pedal into hydraulic force that applies the brake at the wheels. Okay, so that's basically what I have mentioned earlier. Okay, when the brake begins at the brake pedal, when the pedal is pushed down, the brake fluid is forced from the master cylinder into the lines to the wheel brake. As hydraulic pressure increases, brake shoes or pad. Okay, so the brake shoes or pad is where we have the lining brakes that give frictions to the rotating drum or disc. So when we have the frictions, we convert the mechanical hydraulic force or hydraulic energy into the kinetic energy into the heat energy. So that's when we get the car slowing down or stop completely. Okay. So let's go to the first type of brake. We have two types, drum brake and disc brake, right? So let's get started with the drum brake first. Let's watch this YouTube. Okay.
Over sangat pula. Tangan tu kasih soft sikit. Music kena ada feel. Barulah memikat.
Let's take a look at the components that make up a typical hydraulic braking system. We have the brake pedal, the push rod,
Sorry, wrong YouTube.
the servo, the master cylinder,
Okay. This
Drum
is-
brakes are usually used as rear brakes in automobiles. Let's go through the parts involved in the system and see how it works in detail. Brake drum acts as the braking surface on the wheel side. Wheel hub, the part to which the brake drum and the wheel are attached to. Let's have a closer look with the wheel hub off. Backplate. This holds all the brake components together. Brake shoes. These will be pushed against the inner surface of the drum. The friction between the lining and the drum is what makes the wheels to slow down. Hold down spring holds the brake shoes towards the backplate. Retaining springs returns the brake shoes to its resting position. Wheel cylinder, the hydraulic part which pushes the brake shoes. Modern drum brake systems are self-adjusting, which means when the lining wears out, the system adjusts the brake shoes towards the drum. For that, the system uses a brake adjuster lever, adjuster spring. The wheel cylinder receives the force that we applied on the brake pedal. At the back of the wheel cylinder, there is an inlet port to receive the fluid, and a bleeder valve to remove air in the system. Let's have a look at the exploded view. The cylinder body, dust boot, pistons, piston cups, piston cup expanders, return spring. When force is applied on brake, hydraulic fluid pushes the wheel cylinder pistons, which pushes the brake shoes. This action creates friction between the brake liner and the inner surface of the drum, and brings the automobile to rest. The adjuster makes sure that the brake liners remain close to the drum as the liners wear down. As you can see, it uses a screw mechanism to increase its length between the shoes. Each time the car brakes while in reverse, the cog is pulled down by the pin to push the shoes against the drum. And that's how a drum brake system works.
Okay, so it looks like a normal operation of a drum brake. Okay, so basically we have the cylinder there that converts hydraulic pressure into the force on the shoes when we press the pedal. The hydraulic oil or hydraulic pressure goes to the cylinder, and and then it push the shoes and the lining to the disc to the drum brake there, and then the lining there give the frictions, and finally the car will slow down and stops completely. Okay, so for the drum brake types, we have two types here: non-servo drum brake and then dual servo drum brake. Okay, so basically one is without the servo drum brake and one is the dual servo drum brake. Okay, so this is the spring, retainer spring that can retract back the shoes into the original position, and we also have adjuster spring there to make sure when the lining wears down ataupun dah habis lining brake tu, dia akan make sure dia akan makin panjang to make sure the lining still close to the close to the shoes lah. Okay, okay, and then brake shoes are made of metal. A facing of friction material called brake lining is rivet or cemented bonded to the shoes. Okay, so brake lining will be sometimes will be riveted and sometimes will be bonded by using some mechanical cements. And then the lining are usually made of non-asbestos materials such as fiberglass or semi-metallic material that can withstand the heat production braking action. So when the lining is totally wear down, so make sure we have to replace our brake lining, and then that's our preventive maintenance lah, regular maintenance of our car if your cars use the drum brake. Okay, most of modern cars, some will use the drum brake at the rear, and some will use four-wheel, all will use the disc brake. So eventually the drum brake will be phased out from our modern car in the future lah. Okay, so drum brake operations, as what we learned in that video, the leading trail or non-servo brake is used on the rear wheel of many front drive vehicles. Rear drive vehicles usually have dual servo brakes. Okay, in a dual servo brake, the action of one shoes reinforce the action of the other shoes. In a leading trail brake, the action of one shoes does not affect the other. Okay, so you know that the dual servo brake, the action of one shoes will reinforce the action of the other shoes. So it will happen simultaneously and automatically together, synchronized together. That's why the dual servo usually applied to the rear vehicle, rear drive vehicle. Okay, and a leading trail brake, the brake on one wheel will not affect to the other drum brake in the other wheel. Also, let's say when we have a force on the right wheel, right, and then left wheel is not affected by that. But for the dual servo, they will happens, or they will apply simultaneously, synchronously, okay, because it affect each other. Okay, we have another video or not? Okay, never mind. So to get more details for your test preparations, make sure you read one words by one words. Okay, word by words, make sure you understand all the explanation here, detailed explanation here. Okay, because of the test will be only based on these slides. Okay, this is still the drum brake, dual brake servo, and let's get to the disc brake. Okay, so don't forget to read by your own, right? Okay, please understand all the words there, because this is a very detailed explanation. And let's go to the disc brake. So we have covered the drum brake, so right now we are going to learn the disc brake. I have 3 videos there to make it easier for you to understand the disc brake.
Adakah anda simpan duit dalam fixed deposit kerana ia berisiko rendah dan kadar perfaedahnya tinggi daripada akaun simpanan?
Welcome to Autotech Labs. Today we will see how an automotive disc brake system works. Let's see the principle behind the disc brake system. The brake system works based on the Pascal's law. The law states that pressure exerted anywhere in a contained incompressible fluid is distributed equally in all directions throughout the fluid. Let's make it simple. Consider 2 cylinders with pistons, connected each other, and filled with incompressible fluid. The mathematical relation is as follows. F1, applied force on left piston. F2, received force at right piston. A1 and A2 are surface areas of both pistons. P1 and P2 are pressure experienced by both pistons. Pressure can be stated as force experienced per area. So P1 equals F1 by A1, and P2 equals F2 by A2. According to Pascal's law, pressure on both pistons are equal, which gives us P1 equals P2. So, when force is applied to the left piston, the fluid will transmit the force to the right piston surface. But it will be a factor of the ratio of 2 piston surfaces. This concludes that, with a small force F1 at left piston, will give a higher force F2 at right piston, provided if A2 is greater than A1. With this, the left piston can act at the pedal side, and the right piston can act at the wheel side, transferring energy from pedal to the brakes. Now we know the theory, let's see how this works in real. Let's see the exploded view of a car wheel, and the parts involved. The wheel hub assembly, the disc brake rotor, the brake caliper assembly, the wheel, and the lug nuts.
Okay, So these are basic components of a disc brake. Okay, make sure you know every terminologies, the names of that components. Okay, this one is the wheel hub. Okay, similar to the drum brake. And this one is we call disc brake rotor. This is specifically only for the disc brake. We don't have this component in our drum brake. And then we have brake caliper assembly. This is also only in the disc brake. We don't have that in our drum brake. Okay.
The wheel hub assembly holds the wheel and the disc rotor, and the bearing inside it allows their smooth rotation. The disc rotor is the part to which the brake pads squeeze against. This will create friction that retards the rotation of the wheel. The disc rotor produces a lot of heat due to this friction, and the drilled holes provides ventilation to remove this heat. The brake caliper assembly uses the hydraulic force from the brake pedal to squeeze the brake pads to the rotor surfaces, thus creating friction, and decelerates the wheel. The caliper assembly consists of the caliper bracket, slider pins, dust boots, inner brake pad, outer brake pad, caliper frame, and inside it, the
Okay, so this is a very detailed exploded view of a brake caliper. Okay, dust boot, slider pin, this is just the minor components to make sure we prevent the dust, and also to seal the components to seal from the water, and also and etc etc. But the most important things here is the piston. Yes, of course, if you don't have the pistons, we cannot push the force to the force on the brake pad. Then the brake pad will squeeze the rotor, this rotor, and then eventually the cars will slow down because of the frictions between the brake pad and the rotor. So when you change the brake pad, eventually the brake pad will wear down. It will be from the thick there uh, will lessen the thickness over time. So this is what we replace eventually, maybe around 30,000 kilometer every 30,000 or every 2 years or 1 years, based on the manual schedule on your based on your manufacturers lah, cars manufacturers. Okay, so this is the overview, the exploded view of brake disc brake system of the brake caliper.
piston. The caliper frame is having a banjo fitting, through which the fluid will reach till the piston. The pressurized fluid from the pedal side is capable of pushing the piston with great force. Also, the caliper frame is free to slide along the slider pins within the fixed extend. Now we know the parts, let's see how it works. When you apply the brake, the caliper will receive the high-pressure hydraulic fluid from the brake master cylinder. The fluid will push the piston, which makes the inner brake pad to squeeze against the disc rotor surface. As a result, the fluid's backward force will push the caliper frame along the slide pin, which makes the outer brake pad to squeeze against the other side of the disc rotor. Let's see one more time from the top view. The fluid pushes the piston, and the piston pushes the inner brake pad. Once the inner brake pad is pushed against the rotor, the fluid will push the caliper frame. The outer brake pad will now be pulled towards the other side of the disc rotor. This is how the disc brake system works on wheel side. In the next part, we will see what's a master cylinder, and how it.
Okay, so let's see the part 2.
98% akan mengesyorkan sim milik Caliper kepada keluarga dan rakan-rakan.
这是我最喜欢的公公，可是我已经2年没见他了。
Welcome to Autotech Labs. Today we will see the second part of how an automotive disc brake system works. In the last part, we saw the working principle at the wheel side. In this part, we will see how it works at the pedal side. The master cylinder is the main part here. It transfers the force on the pedal to the calipers. There is a push rod, outlet port, and a fluid reservoir tank. Let's see what's inside the master cylinder. There are inlet ports for the fluid to reach the cylinder, compensating ports, primary piston, secondary piston, retaining springs, and piston seals. Now, let's see how the master cylinder works. When you press the brake, the push rod pushes the primary piston, closing the first compensating port. This creates pressure in the cylinder, which pushes the secondary piston, and furtherly closing the second compensating port. Hence both pistons will push the fluid to their corresponding calipers. In case if the secondary piston fails to build up pressure, the primary piston can still develop pressure, with increased travel. And if the primary piston fails, the secondary piston will not receive any pressure to move. So the push rod at the end of the first piston can push secondary piston, which requires much force to be applied on the brake pedal. Even for a fully functional master cylinder, pushing the pistons through the brake pedal requires much force. So later on, another component named boosters were introduced. The brake booster comes between the pedal and the master cylinder, and utilizes the vacuum from the engine, assisting the brake pedal and makes it easier to apply brakes. Let's take a look inside the servo. It consists of a valve rod, dust boot, air filter, valve spring, diaphragm spring, vacuum check valve, hydraulic push rod. When you push the pedal, the valve rod opens the inlet valve, allowing air into the diaphragm front chamber through the filter. This air, along with the vacuum created by the engine in the diaphragm rear chamber, pulls the diaphragm, and furtherly pushing the push rod towards the master cylinder. Thus provides assistance, and reduce the effort in braking. And that's how an automotive braking system works. Thanks for watching, and stay tuned for more.
Okay, so this is a very details that shows you how the force from the pedal into the servo, and the servo into the master cylinder, and finally the master cylinder send or transmit the hydraulic pressure to the caliper if you have a disc brake, and send to the drum brake if you have the drum brake in your car. So as you see that they don't have any electrical motor or so on to pressurize or to motorize the oil there. They only use the vacuum from the engine that give extra force or extra boost to the force there. So that's why if you shut down your engine cars and then you press the brake pedal, and you will push a little more force, okay, but because of the servo here doesn't give you a boost because of there is no vacuum created by the engine, okay. So you have to push by your own force if you shut down the car or the car is broke down, okay. So that's basically the details of mechanism from the pedal into the servo or boost vacuum booster into the master cylinder, and the master cylinder to the brake, either disc brake or drum brake. Okay, so let's see one video more there.
Let's take a look at the components found in a typical disc brake system. We have the wheel hub assembly, the brake disc, the brake caliper assembly, the wheel, and the wheel nuts. The wheel hub assembly attaches to the chassis of the vehicle and holds the brake disc and wheel. A bearing inside the wheel hub assembly allows the wheel and brake disc to rotate smoothly. This vented brake disc consists of two round metal plates, inside which there is a metal venting system. Brake pads squeeze against the disc to create friction, slowing the wheel. Friction creates high levels of heat, but the venting system reduces this heat by helping to circulate air, cooling the disc. The brake caliper assembly provides the mechanism for squeezing the brakes against the brake disc. It typically comprises of a caliper body, carrier, and brake pads. First, let's look at the caliper body. When the brake pedal is pressed, pressurized hydraulic fluid pushes out the piston. When the brake pedal is released, the piston reverts back to its original position. Externally, an outer seal and dust boot protects the piston from dust and contamination. Next, we have the carrier, which is a cast metal frame mounted to the vehicle. It holds the brake pads and caliper body. Two slider pins allow the caliper body to slide back and forth as the piston moves. Brake pads squeeze against the brake disc and produce the friction required to slow the vehicle. At the back of the brake pad there is a shim, which is designed to reduce vibration and noise. Next, we have the steel backplate, which provides the rigid base for the friction material and solid mounting to the caliper piston and carrier. An underlayer, sandwiched between the backplate and friction material, bonds the two together and acts as a thermal barrier to stop heat being transferred from the pad to the caliper. Finally, we have the friction material, which is made from a variety of compounds designed to offer a combination of stopping power, longevity, strength, and comfort. The brake pads are often held in place by springs, pins, or in our case, a clip. These accessories should always be replaced when brake pads are changed. Now, let's see how these components all work together. The brake pedal is pressed and pressurized hydraulic fluid enters the caliper body. Hydraulic pressure pushes the piston out, first forcing the inner brake pad against the inside of the brake disc. As this happens, the inner piston seal deforms. Now, the inner brake pad cannot travel any further, so hydraulic pressure forces the caliper body back along the slider pins, pulling the outer brake pad against the outside of the brake disc. When the brake pedal is released, the inner piston seal reverts to its original position, withdrawing the piston. Let's take another look at this again from above. Pressurized hydraulic fluid enters the caliper body. The piston pushes the inner brake pad against the brake disc. When the inner brake pad reaches the extent of its travel, the outer brake pad is then pulled against the brake disc, slowing the wheel.
Jika anda hanya bergantung kepada
Panasonic FX Front Load series. It eliminates bacteria of up to 90.
Today I'm going to show you what's inside of a brake master cylinder and booster and how it works to stop your car. Now the brake booster is responsible for multiplying the force from the brake pedal onto the brake master cylinder. In the brake master cylinder there are two pistons that push hydraulic fluid from the reservoir